Hello everyone, welcome to today's lecture. Today we will start with chapter 13, an important element. This is a chapter from Science 1. First, what you will be studying about in this chapter: carbon, its occurrence, properties, allotropes, hydrocarbons, carbon dioxide and methane, the occurrence, properties and uses of carbon dioxide and methane. So this chapter could be divided into two parts. The first part I am taking today. So can you recall question? What is an element? The purest form of a substance is called as an element. An element consists of only one type of atoms. What are the different types of elements? Elements can be broadly classified into metals, nonmetals and metalloids. What remains behind on complete combustion of any organic compound? Okay, on complete combustion of any organic compound, the substances which remain is CO2 and H2O. If there is incomplete combustion, combustion means burning. Okay, if the organic substance undergoes incomplete combustion, it will lead to formation of carbon. Next, what type of element is carbon? Give some information about it. The answer for it is given in a box below. Carbon, the symbol of carbon is C. Atomic number is 6. Atomic mass number is 12. Electronic configuration is 2, 4. Valency is 4 and it is a non-metallic element. Now there is a try this question. Take some milk in an evaporating dish. Heat the evaporating dish on a Bunsen burner. What remains behind at the bottom of an evaporating dish is, on complete evaporation of the milk, it is a charred black substance. Okay, so if you burn the vessel which contain milk, okay, after the milk it will get burnt. Okay, so you'll get a charred black substance. Take some small samples of sugar, wool, dry leaves, hair, seeds, split pulses and plastic in separate tubes. Heat each test tube and observe the changes taking place in the substances. What does the black substance remaining in each test tube indicate? It indicates the presence of carbon. Next, carbon. They have given a box. You may fill in the box. The carbon objects, the carbon substances could be divided into three: metallic objects, earthen and glass objects, and other objects or substances. What are the examples of metallic objects which are made up of or which contain carbon, which we use daily? It is cutlery, okay, jewelry, keys, chains, taps, etc. All these contain carbon. Earthen or glass objects. Earthen objects include pottery and handicrafts, and the glass, windows and cutlery. Okay, these also include carbon. Other objects and substances, it includes foodstuff, fuel, medicines, clothes, plastics, wooden objects, etc. So all these objects has carbon in it. Now carbon is a common and important constituent of all these substances. Now there is a can you tell question you may see. What is a compound? How are compounds formed? A compound is a substance which is composed of two or more elements in definite proportions. We had studied this in last year also, this year also. A compound is a substance which is composed of two or more different elements in definite proportions, which is formed by chemical reactions. Okay, they are held together by chemical bonds. You had studied about ionic bond and covalent bond. Compounds obtained directly or indirectly from plants and animals are called as organic compounds, and compounds which are obtained from minerals, they are called as inorganic compounds. Okay, so this is a rough definition. Okay, so the compounds which are obtained from plants and animals, they are organic and mostly it contain carbon, and the compounds which are obtained from minerals, they are called as inorganic compounds. Okay, but there are some inorganic compounds which contain carbon. Page number 139, an introduction to scientists. The German chemist Wohler synthesized an organic compound urea in the laboratory from ammonium cyanate, from inorganic compound ammonium cyanate. Ever since then, many organic compounds have been made from inorganic compounds. Carbon was found to be the main element in all these compounds. Hence, organic chemistry is also referred to as chemistry of carbon compounds. Okay. Now, occurrence of carbon. I have drawn a chart here about occurrence of carbon. Carbon is an element which occurs in nature in free form and in combined form. This is a 3-mark question. The question is there in the exercise. Okay. So, the answer is carbon is found both in free form and in combined form. What are the examples of free form of carbon? Diamond and graphite. So, in diamond, carbon is present. In graphite, carbon is present, or rather diamond is made up of carbon and graphite is made up of carbon. Atoms. Okay. Now combined form. In combined form, carbon is present as carbon dioxide in the form of carbonates. Example, calcium carbonate, marble, calamine. Calamine is zinc carbonate. There is carbon in zinc carbonate. Now this is an objective question. The chemical name of calamine or the zinc carbonate is commonly called as calamine. Okay. Fossil fuel. Coal, petroleum, natural gas, these contain combined forms of carbon. Carbonaceous nutrients, the nutrients which we need like carbon dioxide, carbohydrates, proteins and fats. It contain carbon in the combined form. Natural fibers like cotton, wool, silk, these also contain carbon in combined form. These contains molecules of carbon, that is compounds. They are made up of compounds of carbon. Okay, so that means the carbon is in combined state. So this is the answer for the question. The forms of carbon, that is free form and combined form. Now you may see properties of carbon. Page number 139. Properties of carbon. The first property is allotropy. Allotropy is the property of a substance to exist in different forms. Okay, so different forms of the same element having same chemical properties but different physical properties, it is called as allotropy. Okay, so some elements show the property of existing in different forms. Okay, they exist in different forms. They are having same chemical properties but their physical properties are different. Okay, so those forms are said to be allotropes, and carbon shows the property of allotropy. So carbon shows different forms. Okay, there are different allotropes of carbon. The statement which you have to underline is allotropy. Some elements occur in nature in more than one form. The chemical properties of these different forms are the same, but their physical properties are different. This property of elements is called as allotropy. Besides carbon, sulfur and phosphorus also shows the property of allotropy. Allotropes of carbon. Now I will explain in short what the lecture is about. It is about allotropes of carbon. The carbon has two types of allotropes, crystalline and non-crystalline. What are the properties of crystalline allotropes of carbon? They have a regular definite arrangement of atoms. Okay, they are definitely arranged. They are arranged in a proper shape, proper structure, proper order. High melting point and boiling point. They are having definite geometrical shape and sharp edges and plane surfaces. Okay, so they are having a particular shape. They are having a particular shape. They are having a particular arrangement of atoms. Of which atoms? Carbon atoms. Non-crystalline allotropes, irregular arrangement of atoms. Atoms are arranged in any way. Okay, not in a particular shape or manner. Melt over a large range of temperatures. So every non-crystalline allotrope of carbon is having different temperatures. So there is a wide range of melting point for it. They do not have a definite shape. So these are the two allotropes of carbon. What are they? Crystalline and non-crystalline. First, we will study about the crystalline allotropes of carbon. In our syllabus, we are having three examples. First one is diamond, okay. Second one is graphite, and third one is fullerene. Okay, these are the three crystalline allotropes of carbon. First, we will see about diamond. It is having a tetragonal 3D structure. Okay, tetragonal means one carbon atom is connected to 4 different carbon atoms. That is why it is said to be a tetragonal structure. Okay, one carbon atom bonds with 4 other carbon atoms. Okay, now why one carbon atom can bond with 4? Why 4? Okay, 4 is an important number. Now why 4? I will tell you. The atomic number of carbon is 6. Its electronic configuration is 2, 4. So how many electrons are present in the outermost shell of carbon atom? There are 4. Okay, there are only 4. And how much is needed? 8 is needed. Okay, 8 is the magic number for any atom. So 8 is needed. So in search of those 4 electrons, it shares 4 electrons with other atoms. Okay, so that is why one carbon atom forms bond with 4 other carbon atoms, because it is having 4 electrons in its outermost shell. Okay, so the diamond is having a tetragonal 3D structure. It is transparent and hard. One carbon atom bonds to 4 other carbon atoms by covalent bonds. There are no free electrons. Why there are no free electrons? Because one carbon atom is bonded with 4 other carbon atoms. So all the 4 electrons have been shared. Next, it is a bad conductor of electricity. That does not dissolve in any solvent. Now we will see graphite. Graphite is hexagonal and it is having a layered structure. It is opaque, soft and brittle. One carbon atom bonds with 3 other carbon atoms. Okay, so how many electrons one carbon atom has in its outermost shell? It has 4 electrons. Out of those 4, 3 have been engaged. 3 have got engaged with other 3 carbon atoms. How many electrons are left? 1 electron is left. So every carbon atom in graphite has 1 free electron. Okay, so one carbon atom bonds to 3 carbon atoms by covalent bonds. It has free electrons because every carbon atom is left with 1 electron free. It is a good conductor of electricity. Why it is a good conductor of electricity? Because it is having free electrons. What is electricity? Electricity is flow of electrons. So as it is having free electrons, it is a good conductor of electricity. Next is it does not dissolve in water and kerosene. Now this is a very important question. Distinguish between diamond and graphite. I have written the points. You may write the points as it is. Learn any 4 and write accordingly. Okay, it is a very important question. It is there in the exercise. Now the next is about fullerene. It consists of 30 to 100 carbon atoms. There are too many number of carbon atoms. They include buckyballs and bucky tubes. Now what do you mean by buckyballs and bucky tubes? It is a particular shape which is given to that allotrope of carbon. Okay, the particular buckyball, if you might have seen, it looks like that, so it is said to be buckyballs and bucky tubes. Soluble in organic solvents such as carbon disulfide and chlorobenzene. Now what about non-crystalline forms of carbon? Non-crystalline forms of carbon is divided into 3 types: coal, charcoal and coke. Coal is of 4 types of coal: peat, lignite, bituminous coal and anthracite. Now this differentiation is based on the percentage of carbon present in that particular type of coal. Okay, the first one, that is peat, it contains about 60% carbon. Lignite, it contains about 60 to 70% carbon. Bituminous coal, it has about 70 to 90% carbon. Anthracite, it is having about 95% carbon. So the most pure one is anthracite. Okay, so first, when the coal is formed, the type of coal which is formed first is peat, and from peat lignite is formed. From lignite bituminous coal is formed, and from bituminous coal anthracite is formed. But we are able to get all these forms inside the earth. Now the next is charcoal, and the third one in our syllabus is coke. Okay, so this is an overall view of what you have to study. The question which you have to study is distinguish between diamond and graphite, then the properties of crystalline allotropes of carbon, non-crystalline allotropes of carbon, the properties of diamond, graphite, fullerene, the uses of diamond, graphite, fullerene, coal and coke has been given in our syllabus. So these are the questions. The number of questions from this part is more. Okay, so have you understood? You have to study the properties of diamond, graphite, fullerene, uses of diamond, graphite, fullerene, the properties of coal, uses of coal and uses of coke. Now we will see into the textbook, page number 139. Diamond. Diamond are found in India mainly in Golconda, that is in Karnataka, and Panna in Madhya Pradesh. Diamonds are also found in South Africa, Brazil, Belgium, Russia and America. Now this is an objective question. Now we may move on to the next page, that is page number 140. The structure, we have discussed the structure. So every carbon atom is bonded to 4 neighboring atoms by covalent bonds. Due to this, it is having a 3-dimensional tetrahedral structure. Properties, brilliant and pure diamond is the hardest natural substance. Density of diamond is 3.5 grams per centimeter cube. The melting point of diamond is 3500 degrees Celsius. This could be an objective question also. When diamond is heated at 800 degrees Celsius in the presence of oxygen, carbon dioxide is given out. In this process, no other product besides carbon dioxide is formed because diamond is purely made up of carbon. Diamond does not dissolve in any solvent. Acid spaces have no effect on diamond. Diamond is a bad conductor of electricity as it does not have free electrons. You may mark, this is a give reason question. Why diamond is a bad conductor of electricity? Because it does not have free electrons. Even if there is 1 point, it is a 2-mark question. Now, uses. Diamonds are used in glass cutting and rock drilling machines. Diamonds are used in ornaments. Diamond knives are used in eye surgery. Diamond dust is used for polishing other diamonds. Diamond is used to make windows, giving protection from radiation in space and in artificial satellites. Now the next is about graphite. Graphite is found in the natural state in Russia, New Zealand, America and India. The lead used in pencil is made by mixing graphite with clay. Underline, it is an objective question. This process was discovered by Nicolas Jacques-Comte in 1795. The structure, you may see graphite has a layered structure. So one layer over the other. Okay, every carbon atom in graphite is bonded to 3 other carbon atoms in such a way that a hexagonal layered structure is formed. A graphite crystal is made of many sheets or layers of carbon atoms. These layers slip over each other on applying pressure. One layer of graphite is called as graphene. You may underline, it is an objective question. One layer of graphite is called as graphene. Page number 141. Try this question. Actually, it has been deleted, but you may go through it. Pencil, electrical wires. There are some apparatus which you have to take. The procedure, you may see, you have to remove the lead from a pencil and feel it with your fingers. What color is it? Try to break the lead with your hand. Okay, what color is it? It is black. It can be broken. It is brittle and soft. Assemble the apparatus as shown in the diagram. Start the electric current in the circuit. Observe. What do you find? What will you observe? You may find that the bulb will glow. Why? Because graphite is a good conductor of electricity. Take some water in a test tube. Take some kerosene in another test tube. Put lead dust in both the test tubes. What did you find? It is insoluble in water and kerosene. Okay. Now the properties of graphite. Graphite found in nature is black, soft, brittle and slippery. Inside each layer of graphite, free electrons move continuously within the entire layer. That is why graphite is a good conductor of electricity. This again is a give reason why graphite is a good conductor of electricity, because it has free electrons. Due to layered structure, graphite can be used for writing on paper. The density of graphite is 1.9 to 2.3 grams per centimeter cube. Graphite does not dissolve in most solvents. Uses of graphite. Graphite is used for making lubricants. Lubricants are some substances which are used to reduce friction. For example, grease. You might have heard about grease. Grease which is applied in your cycles. You might have seen the parts of your cycles. Okay, so grease is an example of a lubricant. It is applied to reduce friction, and lubricants could be made with the help of graphite. Graphite is used for making carbon electrodes. Now what are electrodes? Do you remember we had studied in chapter 5, okay, about electrodes, the rods which are dipped into the electrolyte which helps in conduction of electricity. Okay, carbon electrodes. Graphite is used in pencils for writing. Graphite is used in paints and polish. Graphite is used in arc lamps which give a very bright light. Now these arc lamps were used in earlier days. Okay, now arc lamps, it produces an arc of light in between two carbon electrodes. Next is fullerene. An allotrope of carbon is rarely found in nature. It is found in soot. Now what do you mean by soot? The black colored substance which you get on incomplete combustion of any fuel. Okay, so if for a simple example I will tell you, if you take a candle and a candle flame, the flame on the candle, if you hold a spoon on the candle, you get the black colored substance below. That could be called as soot. It is a simple example. Now fullerenes could be found in not in that soot but the sooty particles and in interstellar space. The first example of fullerene is Buckminster fullerene, which is C60. Now this is an objective question. The structure, the molecular formula of Buckminster fullerene is C60. This allotrope of carbon is named fullerene after the architect Richard Buckminster Fuller, because the structure of C60 resembles the structure of geodesic dome he designed. Harold Kroto, Robert Kurl and Richard Smalley were given the Nobel Prize in Chemistry in 1996 for the discovery of this carbon allotrope fullerene carbon 60. Now besides C60 there are other forms of fullerene: C60, C70, C76, C82 and C86 are other examples of fullerene. Now you may see the structure, figure 13.5. Because of that particular structure it is said to be bucket tubes or bucket balls. 142, page number 142, the properties. Molecules of fullerenes are found in the form of buckyballs and buckytubes. There are 30 to 900 carbon atoms in one molecule of fullerene. Fullerene are soluble in organic solvents such as carbon disulfide, chlorobenzene. This is an important question. It is soluble in carbon dioxide and chlorobenzene. Uses: they are used as insulators. Fullerenes are used as catalysts in water purification. At a certain temperature, fullerene exhibits superconductivity. Superconductivity. Conductivity is the ability to conduct electricity. Superconductivity is to conduct electricity with no resistance at all. Okay, so at some lowered temperatures, some substances are able to show superconductivity, and fullerene has the property of superconductivity at a certain temperature. Next is non-crystalline, also called as amorphous forms of carbon. Okay, so non-crystalline forms are also called as amorphous forms. The arrangement of carbon atoms in this form is not regular. Coal, coke are the non-crystalline forms of carbon. Coal is a fossil fuel. It contains carbon, hydrogen and oxygen. It also contains nitrogen, phosphorus and sulfur. It occurs in solid state. It is of 4 types. This is an important question. It is there in the exercise. What are the 4 types of coal? First is peat. It is the first step in formation of coal, and it contains high proportion of water and less than 60% of carbon. So much heat cannot be obtained if you burn peat. Next is lignite. Peat was transformed into lignite due to increased pressure and temperature inside the earth. It contains about 60 to 70% of carbon. It is the second step in the formation of coal. Next is bituminous coal. It was formed as the third step, and it contains 70 to 90% of carbon. Next is anthracite. It is known as the pure form of coal, the last step, and it is hard and contains about 95% of carbon. Now while writing the answer, it is very important for you to write the percentage of carbon in it. Okay, and you have to write order wise. That means the first will be peat, then lignite, then bituminous coal, and then anthracite. Now next is charcoal. The charcoal that is made from animals is made from their bones, horns, etc. On the other hand, the charcoal made from plants is formed by combustion of wood in an insufficient supply of air. So if you burn wood in insufficient supply of air, then whatever you get, that is said to be charcoal. Uses of coal. Okay, actually common people, we don't understand the difference between charcoal, coal, coke. For us everything is the same. We use the common term coal, but there are different non-crystalline allotropes of carbon, like what are they? Coal, charcoal, coke, etc. Uses of coal. Coal is used as fuel in factories and homes. Coal is used to obtain coke, coal gas and coal tar. Coal is used in thermal power plants for generation of electricity. Charcoal is used in purification of water and organic materials. Okay, you know about charcoal clay. Yeah, we are having face packs, we are having face wash, you might have seen. Again, in toothpaste also charcoal is present. It is used in purification. It is used in removal of dirt. Next is coke. The pure coal that remains when coal gas has been taken away from coal is coke. Uses of coke. Used as domestic fuel. Coke is used as a reducing agent. Now this coke is not the coke which we drink. It is given the name coke due to its color. Okay, due to the black color, they might have given the name coke. Okay, so here coke is used as a reducing agent. Coke is used in production of aeriform fuel. Aeriform means gaseous, such as water gas. Now what is water gas? It is a mixture of carbon dioxide and hydrogen. It is used in welding and glass making purposes. And producer gas, which is a mixture of carbon monoxide, hydrogen, carbon dioxide and nitrogen. All these are gases. Okay, and it is used in iron and steel manufacturing and in ceramic and cement industries. Okay, for these purposes they are used. Okay, so these are the uses of coke. So this is this much for today. So today we studied about what are the important questions which we have studied. The first one is the different forms of carbon. The two forms, one is free form and the other is combined form, and the different allotropes of carbon, crystalline and non-crystalline. Okay, so you have to study the properties and uses. Minimum 4 you have to study, others you may read, because objective questions also could be asked from this part. Okay, so you may go through the textbook. If you're having any doubt, you may ask. Thank you.